So far we've looked at variables and pointers, types and structs, receivers, we've looked at maps and slices, and we've looked at decision structures, and now it's time to look at looping over data, which is sometimes called ranging over data in Go. So I have my application open, and I've cleared everything out, and I'm starting with a simple main.go with an empty main function. And let's figure out how we can loop over things. Now when I say loop over things, it means we want to perform some action more than one time. So we do that in Go really simply. We use the keyword for. Now, if you're coming from another programming language, you're probably familiar with different kinds of loops. For example, the while loop, the do while loop, whatever the case may be. But the authors of Go wanted to make things as simple as possible. And one of the things they decided early on was that you really only need one kind of loop. And they're actually right. Anything you can do with a while loop or a do while loop, you can do with a for loop. And we'll get to that eventually. But right now, let's just play with the for loop and see how this works. So the keyword for can be followed with something like this. A variable, which I'm going to call I for index, is assigned the value of 0. That's its initial value. And then it's followed by something you almost never see in Go, and that's the semicolon. It's conspicuous by its absence in most cases, but we're going to use it right now. The second thing we're going to pass to the keyword for is the condition we want to check. I is less than or equal to 10, just like in the if statement. And then the third thing we're going to pass the for keyword is what do we want to do with the variable I each time we go through the loop? Well, I want to increment it by 1, so I'll use the shorthand I++, which is exactly the same thing as saying I equals I plus 1. And then we have our opening and closing curly braces. And in between is what will be executed each time we go through this loop. So I'll just do what I've been doing right along. Log.println. And I'll just say I. Okay. Let's go down to our terminal and run this program and see what happens. Go run main.go. And there it is. I see the value 0 printed on the first line, right up to the value 10 printed on the last line. Now, as you might expect, if I clear the console and come back up here and say I is less than or equal to 5 and run this, it prints 0 through 5, which is pretty straightforward. So the condition is what you check. This is what you do with the increment, the I in our case. We're adding 1 to it each time through the loop, and we give an initial value right here. So that's pretty straightforward. But of course, there are also situations where you want to do more than just to do something a fixed number of times. Now, there are lots of situations where you want to do something a fixed number of times, say 12 times, 1 for each month in a year, or whatever the case may be. But in a lot of cases, you're not sure how much data you have. So let's get rid of this. And let's create a slice of strings, which I'll call animals. So I'll say something as simple as animals is assigned the value of a slice of strings, and then I'll populate it with some values. Say dog, fish, horse, cow, and cat. So now I have a slice of strings, and I can actually range over that slice of strings. And this is something you'll see all the time in Go. And you do it like this. For, exactly the same as we did before, we have our for keyword. This is a for loop. And we're going to have 2 arguments here. I, and I'll call it animal, that's my second variable, is assigned the value of range, and I want to range over my slice of strings, animals. Now, as you can see, I have 2 values, or 2 variables, being returned by the range keyword. The first one is the current iteration, and the second one is the value of whatever I'm ranging through. So I can do something like this. Log.println, and I can just say I and animal. Now, if I go down to my terminal and clear the screen and type go run main.go, you'll see that I have 0 is dog, 1 is fish, right up to 4 is cat. So it starts counting from 0, which isn't unusual. You see that all the time in pretty much every programming language. But there are lots of situations where I don't care about the index. I only care about the value that's in the slice. Can I get rid of the I? Well, if I get rid of the I like this, of course, my program won't compile because it says you've declared a variable inside of a function and you're not using it. And this is where this, the underscore, the blank identifier, comes in very handy. That basically says to the Go compiler, I don't care about this first value that's being returned, just ignore it. That's all the blank identifier means, and you'll see that all the time in Go as well. So now if I come down to my terminal and run the program, go run main Go, you see that we just have the values from the slice of strings. And again, this is very helpful when you don't know how much data might be stored in a particular slice, for example. But you can also range over other things. So let me get rid of this. And instead I'll make a map. And I'll say animals is assigned the value of make a map of string. Now, of course, if I run this right now, nothing is going to happen. We can try it. Go run main Go. Everything compiles, and it just says, well, there's nothing in that map, therefore I'm not going to print anything out. So let's put some values in this. We'll say animals, and I'll say dog, and then I'll put the dog's name in there, equals Fido. And animals, cat, equals Fluffy. Now if I run it, go run main Go, we get the names of the animals. Well, that's helpful, but what about the actual kind of animal that might be associated with a name? I might have, for example, a horse named Charlie, and Charlie doesn't tell me anything. It doesn't tell me what the kind of animal is. Again, I can come back here and put animal type, and then just put in my log print line, animal type, and a comma. Now if I run it, it will print out both the key and the value. Dog is Fido, cat is Fluffy. No problem. And of course you can range over slices, you can range over maps, you can also range over other types. You can even range over a string, for example. So let's just clear this out and put a string in here. Var first line of something, some song or some poem, I'll put a poem. We'll see something like, once upon a midnight dreary. A little Edgar Allan Poe. Now I want to range over first line. And of course this is not a shorthand operator, this has to be an equal sign, so let's fix that. And now I'll say I and L for letter. I for index and L for letter. Log.println I, and then a colon, and then L. So I'll clear the screen and go run main Go. And there it goes. It prints out everything that you see in there. Now, you might notice that if you look at the values that are printed to the console, we have I incrementing by 1 each time, which is exactly what we expected, but then we have a number instead of the letter, which seems unusual, and that's because in Go, a string is actually a slice of bytes. Now, if you read the documentation, it will also say a string is a slice of runes, but then if you go read the documentation for runes, R-U-N-E, you'll discover that a rune is actually a byte. So this is not surprising. Now, we could modify this to actually print out the letter, but all I care about right now is how we're looping through things. So just so you know, a string is a slice of bytes, and although I can change the value of a string, something like this, I could say first line is equal to X. That appears to simply modify that string. But in reality, what's happening behind the scenes is a lot more complex than that. Strings in Go, as is the case in many programming languages, Java for example, they're actually immutable. So when you overwrite the value of a string with something else, you're actually destroying one object in memory and creating an entirely new one. So that's just something to be aware of, and we'll talk more about that later on in the course. But for right now, let's focus upon looping and ranging. So we can range over slices, we can range over maps, we can also range over strings because they're really a slice of bytes. We can also range over our custom objects. So let me create something else here. We'll get rid of this, and we'll get rid of this. And we'll create our own custom type, and I'll call it user. So I'll create a type. User is a struct, and that has some members inside of it. So let's create one called first name. First name, which is a string. Last name, which is a string. Email, which is a string. and age, which is an int. Now let's format this, and then create a variable, which I'll call users, which is of type slice of user. Now let's put some values in there. So users equals append users, and I'll append the type of user, and I'll just populate its data this way. So first name is John, last name is Smith, email is john@smith.com, and John is 30 years old. Now I'll duplicate this a few times, say 3 more times, and I'll put in Mary, Jones, and I'll make Mary's email mary@jones.com, and I'll put in Sally Brown, and we'll just make that Sally@Smith, and then of course we need one more, say Alex Anderson, and we'll make that Alex, and we'll just change their ages just so we can see that things are different. So 20, 45, and 17. Now I want to range through my users. And I'm going to ignore the index because I don't care about that. And now I'll print out information. So format, or log.println, and now I'll print L dot first name, and L dot last name, and L dot email, and L dot age. Okay, so let's clear the screen and run our program. Go run main.go. And as you can see, it prints all of the information out, 1 entry per line. So that's how you range over things. And we'll be ranging over things all the time in this course. For example, at some point, we're going to be querying the database, getting a slice of custom types, and doing something with them. And range is the tool we use to do that. And of course, range is just a variation on a theme. It's a variation or a type of for loop. Loops are critical, and we'll be using them all the time. So let's move on.